This is Rges Algebra 1, and we're in Lesson 2.6, Commuting and Associating. Okay, these are two important properties among real numbers. And so to commute means to change the order. As though I were commuting, I'm traveling in traffic. I'm commuting to and from work. I am moving. Okay, so I want to move my numbers. To associate means to leave the numbers in the same place, but group them. So for this, I only need two variables on each side, or two numbers on each side to commute, but I need at least three to associate. Okay, so if I were to talk about the commutative property of addition, I would have two things I'm adding together, let's say 7 plus 3, and I could move the order. I could say that equals 3 plus 7, where the 3 has gone first and the 7 has gone second. And we know that that's a true statement. 7 plus 3 is 10, and 3 plus 7 is 10. So commutative property works for addition. In addition, no pun intended, additionally, it works for multiplication. If I have 7 times 3, I could change the order, putting the 3 first and the 7 second, and indeed 7 times 3 is 21, and 3 times 7 is 21. So we call these properties the commutative properties of addition and multiplication. Now, to associate, I would need at least three things to illustrate it. Let's say I have 7 plus 2 plus 3. And let's say I want to associate the first two, and I'm going to write the numbers in the very same order, 7 plus 2 plus 3, but now I'm going to associate the last two. Is that a true statement? Well, in the first, on the left, I would get 9 plus 3, that would be 11, and on the right, I would get 7. 9 plus 3 is 12, there we go. I would have 9 plus 3, or 12, and on the right hand, I would have 7 plus 5, or 12. So we know that it does, in fact, work. This is a true statement for addition. Now let's look at multiplication. What if I had 7 times 2 times 3? And I associate the first two. Does that equal 7 times 2 times 3? Notice I'm not changing my order, but I'm associating them different. So again, you need at least three values to illustrate association. Well, let's see if this works. I get 7 times 2 is 14, times 3 more, that would be 30, 42. And on the right side, I would get 7 times 2 times 3 is 6, and 7 times 6 is 42. So this is indeed a true statement. Those are equal. So what have I shown you? I have shown you that the commutative property of addition and the commutative property of multiplication. I've shown you the associative property of addition and the associative property of multiplication. Now notice, this does not work, not for subtraction, division, or powers. And so I want to refer you to page 67, where he'll illustrate that, and page 68. On 67, he illustrates that for the commutative property, and on 68, he illustrates it for the associative property. So I'm not going to rewrite that here, but make sure you understand these properties work for addition and multiplication, not subtraction or division or powers. Now let's look at the basic problems, types of problems we're going to do. Number one, it says 3 plus 2x plus 7. Okay, and we have addition here, and I can switch the order of these two. So I could say that equals 2x plus 3 plus 7. That was commutative. I could decide to associate these, and I would have 3 plus 7, or 10. So I'm showing you several steps to do a fairly straightforward, simple problem, showing you that it's valid to combine them like this because of my associative and commutative properties. Now I want to look at this problem again here on the right. It says 3 plus 2x plus 7, and I want to simplify this. Constants can be added to constants, but x's can only be added to other x's. For instance, if I had a plus 3x here, I could combine these also, but I don't. I don't have a plus 3x, so I can't combine the x's. But I can combine those. It's fine with me if you don't write out the steps on the left here, but you just say, okay, I only have one term with the x value. That would be 2x. I have two constants that I must join. That would be 10. So that's the way I think I'd like you to do this. Let me show it to you again on the next example problem. It says 7 minus x minus 12. Okay. Well, I'm going to, the x term, which is this one right here, has no partners, but these two have a partner. So this is the same as negative x, and now combine 7 minus 12. I'm going to write it down over here, but I think you can do it in your head. 7 minus 12, if you can't, go ahead and write it down. Okay, but 7 minus 12 is the same as 7 plus a negative 12. We have opposite signs, so we're going to take the difference between 7 and 12, and that's 5, and the sign will be the negative because I went further in the negative direction. I went 12 to the left of 0 and 7 to the right of 0. So I would copy that over here. And that's how I simplify this. This statement simplifies to that. Now, if you think this is a little bit of a leap for you intellectually, go ahead and look on page 69 and feel free to do it as methodically as he is showing you. Let's look at another one, 12x times 1/4. Because of the commutative property, I could combine this is the constant part and this is the constant part. So I could write these next to each other. 12 times 1/4. And recall 12 times 1/4 is the same as 12 divided by 4 times x. Well, 12 divided by 4 is 3 times x. Recall that if you have a 3, a number, a constant, and a variable written right next to each other with nothing in between, it means you are multiplying. That is the same as that. Okay. If you look at the next one, it says negative 7x over negative 7. Again, the way I'm going to look at this is I'm going to take the constant parts and write them together, and then I'm going to write the x. A negative, first off, a negative over a negative is a positive, and any number over itself is 1. 5 over 5 is 1, 3 over 3 is 1, because I could just divide both the top and the bottom of the same number. So this would be the same as positive 1 times x, And I do not need that because anything times x is the same as x. So this is your best answer right here. So I want you to skip the oral practice, and when you are going to do the problems, I want you to show whatever level of detail is necessary for you to simplify these. Let's just look on the next page just a little bit. I would like you to look on page 71, exercise 2.6, beginning the middle of the page, and I'm going to just walk down these with you, giving answers. You are to do the odd ones at home, so let's just look at these. I'm combining the constants. So number 2 would be x plus 9. Number 4 would be x plus 21. Number 6 would be x, and I have a 7 minus 9, so I would have x minus 2. Number 8 would be x. I have 11 minus 3, which is 8, so it would be x plus 8. Number 10 would be negative x, and then you're going to add your 16 and 5, so negative x plus 21. Number 12, negative x. You've got 12 minus 15, so I'm going to take the difference, which is 3. It'll be negative, so I'll have negative x minus 3. And so you can go on with those. You're going to be doing the ones on the left-hand side, but I just wanted to illustrate with you for a little bit how you're thinking mentally as you're going through these. Okay, I think that's all we'll do there for right now, and I'll probably review that again with you in class once you get a little more practice under your belt.